Significant digits are a way for scientists to show you what's been measured in a lab. So if you've ever looked at your lab and wondered, why am I writing down 15.00000, you're writing down exactly what was shown on a balance or exactly what you measured with a ruler, whatever the case may be. So significant digits are important for us in labs to be able to express exactly what we measured and not just make up a bunch of random numbers or leave numbers out that we actually did measure. So in order to do this, we are going to just talk about how to identify the number of significant digits. And again, all significant digits means are what numbers were measured. And we use what's called the Atlantic Pacific rule. And really all that is, and you'll see this down below, is if a decimal point is present, we're going to start on the left-hand side of the number. We're going to go left to right and find the first thing other than 0 and count that place value along with every other place value going left to right. And that will tell us how many place values were actually measured by whatever device we were using to measure. If the decimal point is absent, which is the Atlantic side of the US, we start right to left, and we go right to left until the first number other than 0, and count from that place value on, and those will be the place values that were measured. So let's try a couple examples down below and see how this goes. So for the first number over here, 7.666, there is a decimal point present, so we start on the left side. The Atlantic Pacific rule, this is the Pacific side of the US. And we're going to go left to right. So I'm just going to draw an arrow. You don't have to do that, but that just shows me which way I'm going. I'm going to go left to right, and I'm going to find the first thing other than 0. That's the 7. So I'm going to count that place value along with every other place value. So that's 1, 2, 3, 4, 5, 6, 7. So what that means is there are 7 significant digits, or all 7 of these numbers were actually measured by whatever instrument was doing the measuring. For the next one, there is a decimal point present. So again, we're going to go left to right. Find the first thing other than 0, it's the 2, and just count that and every other place value. So 1, 2, 3, 4, 5, 6, 7, 8, and we're done. For the next number here, there is no decimal point, so it's absent. We're going to start on the Atlantic side or the right side, and we're going to go right to left. We find the first thing other than 0, which in this case is the 8. So we're going to count that along with every other place value going right to left. So 1, 2, 3, 4, 5, 6. Down here, no place value or no decimal point present, so we're going to go right to left. Find the first thing other than 0, it's the 5. So 1, 2, 3, 4, 5, 6. This middle number here, their decimal point is present, so we start on the left side, the Pacific side, and go left to right. First thing other than 0 is the 3, so 1, 2, 3, 4, 5, 6, 7, 8. Last number here, there's a decimal point present, so again, we start on going left to right. First thing other than 0 is the 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's just identifying the number of significant digits. You're also responsible for multiplication and division problems. For these, I'm never going to have you actually solve the problem. All I want you to be able to do is identify the number of significant digits in each number involved in the problem and circle the lower number of significant digits. The reason why you circle the lower, your answer can only have as many significant digits as the number that had fewest to start with. Basically what that means is just because you're doing math doesn't mean you can end up with an answer that's more precise than the measurements you were, or the instruments you were using to measure to begin with. So if we look down here, at the first example we have 56.898. There's a decimal point present, so we're going to go left to right and count 1, 2, 3, 4, 5 significant digits. 5298, decimal point is absent, so we're going to go right to left. 1, 2, 3, 4. 4 is less than 5, so that is the number of significant digits that our answer can have. And that's all you need to be able to do. For the next example, decimal point absent for 3258. There are 1, 2, 3, 4. For here, decimal point is present, so we're going to go left to right, and we go, first thing other than 0 is the 8, so there's 1, 2. 2, circle the lower number. Down here, decimal point present, so left to right, 1, 2, 3, 4, 5. Decimal point present, left to right, first thing other than 0 is the 9, so there's only 1, and that's your lower number. So significant digits, all we're looking for is the number of place values that were actually measured, and that's all we're doing is follow the Atlantic Pacific rule. It's pretty straightforward as to what your answer is going to be.